Okay, so today we're going to look at a lab where we're dealing with the dehydration of a compound. Okay, and what it's going to tie into is going to tie into looking at percent comp, kind of what you guys were doing yesterday online as well. So what we have today is we have copper 2 sulfate. So if we remember, if it's copper 2, that 2 tells us something about the copper. And what the 2 is going to tell us, it's not going to tell me how many coppers I have, but it tells me the charge. So I've got copper, the 2 plus charge, and then sulfate is SO4 with the 2 minus charge. So right there we've got a balanced compound, plus 2 minus 2. So copper 2 sulfate, CuSO4. And this compound is actually a pentahydrate, so times 5H2O. In other words, what that's saying is per every 1 copper sulfate, there are 5 water molecules that are attached around that compound. So it's actually wet, all right? You could say, or hydrated. There's water on those molecules. Let's take a look at what that looks like real quick. Okay, so here is what copper 2 sulfate looks like. All right, now this is it crushed up, and if you look at it, it doesn't really, most people would not say this looks wet. Okay, it's a pretty dry powder. Let's see if I can get it to focus on my finger there. Okay, pretty dry, but it's got this blue kind of tinge to it. Okay, and what copper ions, when they've got a blue tinge to them, okay, when copper has this blue tinge, these copper 2 ions, it means that there's water molecules around it, all right? And we saw that there's water molecules around that. So what we're going to try to do is we're going to try to drive this water off, okay? Well, one of the ways to drive water off, a good way to get rid of water is to heat it. So that's what we got going on over here right now. So we've got this set up here. We've got a crucible up top here, okay, with the lid kind of cracked on it, and then we've been heating it, or I've been heating it with a Bunsen burner here for a little bit to drive off that water. And we'll come back here in a second to take a look at what that looks like. All right, but that's what we're doing. If you want to dehydrate something or get an anhydrous compound, so when it's hydrated, it's called a hydrate. Okay, when that means it's got this water molecules on it. But if we drive these water molecules off, it would be an anhydrous, or without water. Right? So some data that we're going to need for our lab right away on the back of it. So I measured the crucible and the cover before I started heating it up, and it was 35.4, and I should have a 0 on there, 35.40 grams. And then I measured the crucible and the cover with the hydrated compound. And remember, what's our hydrated compound? Is this copper sulfate pentahydrate. All right, so after I put some of that compound in there, it was 38.42 grams. All right, and then I went ahead and put that on the Bunsen burner and started heating it up. So what we did with the heating is we slowly heated it up, or kind of lightly, and I'm going to kind of crank up the temperature here a little bit, and we'll heat that up for about another 10 minutes. And when that's done heated up, we'll come back and take a look at what we have. So remember, here's what the compound looks like before it was hydrate, or as a hydrate, with those 5 H2O molecules on there. And we'll take a look when this is done heating what it looks like after it's dehydrated. Okay, so we're back here. It's been about 10 minutes or so. We've been letting this stuff heat up, cool down. It's probably been a little longer than 10 minutes. So let's take a look at what the compound looks like now after we have dehydrated it. If I can get the camera to flip here. Okay, so here's what it was right before we heated it up, that blue compound like that. And let's take our lid off, let's take the lid off the crucible here and see what it looks like after we have dehydrated it. Okay, so what you can see looking at that is obviously a much different looking compound Sorry, my phone is going crazy here. Let's see if I can study it out. So it's a lot different looking. Let's zoom in there. So it's a white powder, still a powder though. If I kind of get my, okay, so it's dry, but it went from, you know, this nice blue color here to now it's kind of a white color. All right, and that's an indicator. The white is an indicator that there's no more water around on that copper sulfate. Okay, so that's what we're getting there, is that water has been driven off, and that's the case. So let's take a look. Let's put that on the scale and see how much it. Okay, on the scale there, so this is with the anhydrous compound, or after it's been heated. We've got a weight of 37.45 grams. Okay, so that gives us our final thing is crucible, cover, and anhydrous compound, and it was 37.45 grams. Right, so that's all the data that we're going to need in order to solve this lab. Okay, so we have the weight of the crucible and the cover, the weight of the crucible, the cover, and the hydrate, so that's with the water. After we heated it up and drove all that water off, it weighed that much, and again, that's the crucible, the cover, and the compound. So that should be enough to be able to figure out what percentage of this initial compound was actually due to the water. So go ahead and finish up those calculations on your lab, and when you're done with it, turn that into Google Classroom. Hope you guys have a great day.